I'm going to look at 6.19 in the workbook. Zombies pushing around some blocks. And so if you want to follow along, that's great. You've got the solutions. Maybe you just want to follow along until you get to the force equations. Make sure you're doing things correctly. Oh, I better hit the pause button. I don't get distracted there. And then, whoops, we got block 1, block 2, and then the floor. I'm going to push horizontally on the lower block. So I'm going to push horizontally with some magnitude F on this lower block. And let's see what assumptions we have. What are the knowns and unknowns in this problem? According to this, it says it's pushed by a force with magnitude F. So I'm going to assume F is a known quantity this time because it was given. We know mu static equals 0.600. We know that 3 sig figs is absurd, but we also know engineers tend to write things with 3 sig figs unless otherwise specified. In this case, we see mu kinetic is a little bit lower. That's fine. And then, oh, I can see later we're going to have, okay, so as I read through this problem, it's not exactly clear what's given and what's not, but I'm going to assume M1 and M2 are given. And let's face it, what really matters, what's really going to help you succeed on test day? In this case, drawing the FBDs, writing the force equations, and then on exam questions, I'm usually a little bit more clear about what exactly is given. And remember, if you don't know for sure, you can always raise your hand and ask during the test. And come around and say, hey, is this supposed to be a known quantity or not? And I'll just tell you that if it's not clear. All right, so in this case, I suppose we should assume G is given too, right? And so F, I'm not sure if that's given or not. Let's leave that out for right now. So maybe we're looking for a certain F that causes acceleration or not. I don't know if we know the acceleration or not. In part B, I notice it says A is this, find F12 and capital F. I don't know why, but for some reason in this problem, I chose to set G equal to 10 meters per second squared. So notice there's going to be some rounding here. Okay, fine. I don't know why I did that, but it doesn't matter. All right. Step 1, FBD's force equations. Get that done. Race you, okay? Try not to look at the screen. Do your work yourself, and then look up when you're done, or hit pause. That way you don't have to race. Okay, so I'm going to go ahead and proceed right now. Maybe I'll do FBD 1, FBD 2, and then at some point it says these are still moving as a single unit. So we could, in theory, do a system FBD. Again, that's an optional thing. So in general, stay away from that unless you know you can use it. I'm going to assume that these are accelerating this way. I'm going to do one last check. It says the frictional coefficients for all surfaces. So right here. So for all surfaces, we have that. So FBD 1. All right, here we go. I'm thinking this block stays on top of there. If there was no friction, it would fall off the back. It would tend to fall off the back. The direction of relative motion, or the tendency of relative motion, would be backwards relative to 2. That means there's a frictional force forwards on 1. So there's a frictional force forwards on 1. I'm going to call that friction 1-2 because it occurs at the 1-2 interface. Now, there's a normal force upwards. I'm going to call that normal force 1-2. All right, because that comes from the 1-2 interface, not from the floor. There's a weight pulling down. It's not mg, it's m1g. And then that's it. Cool. Here we go. I'm going to FBD 2. This is a tricky one. Okay, in this case, I know that there's a force this way with magnitude F because some zombie's pushing on it. Got it. Well, I know that the floor must be supporting this. So I'm going to call that normal force 2, because it's from the floor. Remember, N2 is usually our shortcut for N2 floor, the normal force between 2 and the floor. Now, in this case, there's the weight. I'll call that M2G. And now we're going to run into trouble here. There's friction with the floor, but there's also friction up here. So I happen to, well, I expect the floor is going to pull back on it. I'm going to do the easy one. I'll call that friction 2. These two are linked together. Why? The normal force at the 2-floor interface produces the friction at the 2-floor interface. Okay, got it. Now, what about this normal force? 1 is pushing down on 2. So that's the action-reaction pair. One of the forces is on 1, the other one is on 2. Now, a lot of you are saying, why can't I just say M total G here? In this one case, you can. However, isn't this taking care of that for you? This is the right way to do it. Do not just get in that head. I know from experience, every once in a while, students will write M total G and it's wrong. However, it is a normal force down. If you care, the example would be, what if you're in an elevator accelerating upwards? If for some reason that was the case, N does not equal mg, which means M2G would not be the downwards force, it's N12, which would relate to mg and the acceleration. Enough said. Do not write M1G downwards here unless the acceleration is 0. In this one case, that happens to be true in the y direction. You could have done that, just don't. Got it. Now let's think about this. 1 is being pushed forwards by friction, right? The friction caused by 2, or 2 exerts a frictional force to the right on 1. By Newton's third law, 1 exerts a frictional force to the left on 2. Now look at this thing, will you? These are an action-reaction pair. These are an action-reaction pair. These are not. This is just something else, okay? Now, the cool part about this is the internal forces drop out. So the forces at the 1-2 interface should drop out on the system FBD. That's these two. So in this case, we could draw a system FBD. And now check this out. It's a little bit weird here. In this case, I get M1 plus M2G. Like I said, in this one case, N12 happens to be M1G. That's why that works out. There's a normal force upwards. Some of you might be saying, I want to use N. That's true, but isn't that N the same normal force as N2 that we've already labeled? So why should we introduce a new one when this force from the floor on 2 is that same force right here? We do not want to have extra variables floating around to confuse ourselves. Again, in this case, the floor on 2 is the total normal force from the floor. I'm going to keep it with that label instead of dropping the subscript. Next, I've got, in this case, friction with the floor is external, right? 1 and 2 are the system. The floor is outside the 1-2 system. The floor friction is still there. Now I'm starting to get a little bit lost. Let me make sure I didn't screw anything up. There's a normal force from the floor on both of these blocks combined. There's the friction for, or the force from the zombie. There's friction from the floor, and there's the weight of everything. I believe we've got it. Doing a quick check. 1, 2, 3, 4, 5, but we combine 2 of them. 1, 2, 3, 4. That looks good. Now in this case, these are accelerating to the right. So I might as well use a normal coordinate system. All right. And so at this point, I've got my FBD. I can write my force equations. So in this case, I guess I see that F12 is equal to M1A. It's not MA. It's M1A because I'm looking at mass 1. And over here, I see that N12, in this one case only, happens to equal M1G. Can you tell what frustrates me when I grade tests and students just always assume that's true? It drives me crazy. All right, in this case, in the X direction, I get F minus F2 minus F12, because there's 2 frictions on this block, one from the bottom and one from the top, one at each interface. And then that's it. equals not MA, but M2A, right? Because it could be a different math. All right, that's fine. And then over here on this one, I see that F minus friction 2 is equal to M1 plus M2. I'm running out of Rome. Yikes. Is that still visible? Apologize, that's a little small. But basically this minus this is M total A. Notice if I took this equation and plugged it in for that, I get the system equation. The system is a shortcut. It doesn't always work. These always work. So if you're confused about the system FPD, or if you're not sure if it can be used, do it this way because it always works. Oh, I forgot the Y direction here, didn't I? In this case, I see N2 up equals the downs, M2G plus N12. Notice I could plug this one into here and very quickly get, oh, in this case, N2 is the total weight, which is exactly what we see here, which is why we didn't renumber that subscript. All right, so at this point, great. We've got some force equations you might be able to solve for something. If you read the question, I think it says solve for some stuff and plug in some stuff. One of the things you want to watch out for, basically, I'm fine with you following the solution in the workbook from here. I'll put a link to it just so you got it if you're not familiar where that is. But in this case, there's a lot of different problems you could do with this. You could say, what's the hardest you could push before this falls off the back? Well, if that's the case, if you push this really hard and it's about to fall off the back, it's about to slip, you could say this one's on the verge of slipping. Now, keep in mind here, the bottom one, it is slipping. So for the lower friction down here, what is that, F2? F2, we're going to use mu kinetic times the normal force 2, whether the top one slips or not. And then where this gets tricky is F12 at this interface, it's unclear. If it's on the verge of slipping, this is about to fall off the back, I would use mu static times the normal force. I know it's moving, but remember, it's not moving relative to 2. Whereas, what if it's just riding along there and not having any trouble and not slipping? Well, if that's the case, I don't use anything. I just say, look, if you tell me the acceleration, I'll tell you what F12 is. So this is very tricky. There's a bunch, and I believe parts B and C ask you to figure out some of these different things. So you can look at parts B and C. For now, that's more than one, right? That's free body diagrams and force equations. That's good. I'll put a link to the solution in there, and you can hit Control-F and search for 6.19 and you'll find it. All right, that's pretty good.